All right, this lesson is an overall review of our unit on Introduction to Polynomials. We have a test coming up, so we're going to touch on all of the different things that we have covered in this unit. All right, now there's no way to fit every single thing onto two sides of a sheet of paper. So if you really want a thorough review, you notice this is day 13. You need to go back and look at day 1 through day 12 and make sure you know everything on those documents. All right, one of the things we learned how to classify polynomials. So let's review that a little bit. Classifying polynomials. One way to classify polynomials is by degree. So, if the degree is 0, that is a constant. If the degree is 1, that is linear. If the degree is 2, that is quadratic. If the degree is 3, that is cubic. And if the degree is 4, that is quartic. Okay, so memorize that. And remember, as far as degree goes, it's all about the highest power. So, if I have 2x to the third power plus 5x squared, the degree is 3 because that's the highest power, and that would make this cubic. All right, we can also classify according to the number of terms. If there's just one term, it's a monomial. If there are 2 terms, it is a binomial. And if there are 3 terms, it is called a trinomial. All right, 4 and higher, we just have to go with polynomial. All right, problem number 2, standard form. If you have a polynomial in standard form, it should be in order from the highest degree term to the lowest degree term. So the highest power is 4th power. So first I would put negative 4x to the 4th power. All right, notice the sign goes with it, negative 4x to the 4th power. Next power I see lower than that is negative x squared, so that comes next. There is no 3rd power. And then next I see this plain x, so I'll put plus x. And then finally I see the constant term, plus 2. And I really should put, f of x in front of here, but I was afraid I was going to run out of space. All right, somebody's going to have to read this later, so I'll put it up high. Okay, that's your standard form. Now, if it's in standard form, the leading coefficient will be the coefficient in front. So the leading coefficient is negative 4. But even if it's not in standard form, maybe I don't ask you to put it in standard form. If I just give you this function and I say, what's the leading coefficient? Even if it's left like this, the leading coefficient is still negative 4. All right, it's still going to be the coefficient of the term with the highest degree, the highest power. The constant is the term that has no variable. So the constant is 2. Now, named by degree, the degree is 4, so this is quartic. Named by the number of terms. Well, this has 4 terms, so polynomial. All right, this is a quartic polynomial. And if it was 5 terms, 6 terms, 7 terms, we would just still go with polynomial. All right, I guess that's it for number 2. All right, number 3, when you are adding polynomials, It's really, you're just combining like terms. The parentheses are just there visually to help you see this is one polynomial and here's another one, but none of the signs change or anything. So you can just really ignore the parentheses and go on ahead. We want our answer in standard form. So let's look for the highest degree, the highest power. The highest power is this one, the third power. I don't see any others, so I'll just bring that one down. 14x to the third power. Okay. Now, are there any second power? Well, I see x to the second power and 3x to the second power. This is sort of like 1x to the second power. So 3x squared plus 1x squared is 4x squared. Okay, notice the exponent part doesn't change when you combine like terms. So we have 3, 2. All right, do we have any single x's? Okay, I have a single x here and a single x there. But this is like positive 1 and this is like negative 1. So together that makes 0. They cancel out. So, you know, they really just are canceling each other out. So we won't put any x's. And then finally, we've got the constant term, 7 and 2. So that together they make 9. So there is your answer for number 3. I see number 4 hiding over here already. All right, the main thing to watch out for is this negative sign right here, because this is like a -1, and it must be distributed across the trinomial. All right, you can't just erase the parentheses. So let's focus on this part first. If I multiply all of these by -1, then I'm going to have negative 3x squared minus 2x plus 5. All right, meanwhile, this binomial doesn't have anything in front of it to multiply. So I can just erase these parentheses and bring down the 1 minus x squared. So now we look for the like terms. So we have like terms. Let's go with the highest power first. We have negative x squared and negative 3x squared. If you put those together, you know, this is like negative 1x squared. So now we have negative 4x squared. All right, next we look at the x term, and we have one of those, so that's going to give us negative 2x. And then last, let's take a look at the constants. And so we have the 1 and the 5, and together that makes 6. Okay, that's why this is the final answer. I saw number 5 hanging out over there. So a little multiplication. When you have a monomial and then a polynomial, you know you're just doing the distributive property. Just be careful. 3 times 2 is 6, but x squared times x squared is x to the 4th power. All right, this is the one where they increase. You're sort of adding these two together. Now, let's do 3x squared times 9x. Well, 3 times 9 is 27. X squared times x is x to the 3rd power. And finally, 3x squared times negative 6. 3 times negative 6 is negative 18. And then we've got the x squared. So there is your answer for number 5. All right, now if you want to multiply by a binomial or a trinomial, you are still doing the distributive property, but you are going to do it more than once. So for example, I could start by distributing this x like this. Okay, just ignore the negative 1y for a minute. If I do x times x squared, that's x to the 3rd power. X times negative xy is negative x squared y. And x times y squared is positive x y squared. Get in the habit of putting the variables in alphabetical order inside of the monomials. So, okay, I distributed the x. Now, I'm going to distribute this negative 1y, negative 1y, okay, times each of these things. Well, negative 1y times x squared is negative x squared y. I'm noticing I already have an x squared y, so I'm going to line those up. So that's going to be negative x squared y. Do you see it? Now, negative 1y times negative xy. Okay, first of all, a negative times negative is positive. All right, now the x is just sitting there, but you know y times y is y squared. Okay, y squared. So negative 1y times negative 1xy, this could be like a 1 as well, gives me positive xy squared. And look, there's an xy squared right there, so I'm going to line those up. But I still got one more to do. I'm doing negative 1y now times y squared. All right, negative 1y times y squared. Well, that's going to make negative 1y to the third power. And there's nothing to combine that with, so, and I'm going to drop the 1. So it's just negative y to the third power. All right, let's go ahead and combine these like terms. The x to the third power doesn't have a like term, so we'll just bring that down. All right, and this is like negative 1 of these and another negative 1 of these. So together that makes negative 2 of these. So negative 2x squared y. This is like positive 1 of these and another 1 of these. So that makes 2 of these. And then the negative y to the third power, you just bring that down. So this purple would be your answer to number 6. All right, look at number 7. We need to do f of x minus g of x. Make sure you put these functions in parentheses. Now here's function f right here. Okay, so I'm going to start with that. 2x squared plus 5x minus 3. And then we need to subtract g of x. Well, function g is right here, so we're going to subtract negative 4x squared plus 5. Okay, that one went a little off camera, but there it is. It's just so this is just like the subtraction problem we did above. So just remember, the main thing is to remember that this is a negative 1 that we need to distribute. So negative 1 times negative 4 is actually a positive 4x squared. Negative 1 times positive 5 is negative 5. Now the blue part is just going to come down unchanged. So it remains 2x squared plus 5x minus 3. Okay, let's look for those like terms, people. Well, I've got 2x squared and 4x squared. That makes 6x squared. Now, then I've got 5x, right? But there's no other x term, so I'm just going to bring that down. And then the constant, negative 3 goes with negative 5 and makes negative 8. So this should be your answer for number 7. Okay, number 8. All right, this will be the last problem of this video. So we need to multiply function g times function f. So let's see, function g, that was this, okay, negative 4x squared plus 5. Okay, so negative 4x squared plus 5. That's function g. All right, what about that function f? Maybe I can just cut and paste this right quick. All right, this is function f. Just going to bring that over, Kabam, that's pretty slick. I know you like that. All right, so now we're going to do our double distributive property like you do. Let's see. I'm going to go green with it. So I'm going to do the double distributive property like this. Okay, so here I go. Negative 4x squared times 2x squared. Well, negative 4 times 2 is negative 8. X squared times x squared is x to the 4th power. Well, there's the bell. I'm going to have to pause. I'll be back so fast, you won't even know I was gone. Then negative 8x to the 4th power times 5, I'm sorry, not negative 8 to the, multiplying negative 4x squared times 5x. Negative 4 times 5 is negative 20. And x squared times x is x to the 3rd power. Okay, and then I'm multiplying negative 4x squared times negative 3. Well, negative 4 times negative 3 is positive 12. So that'll be positive 12 x squared, because we got the whole x squared thing happening. Alrighty then. In your face! Now we're going to distribute this 5 like this. Okay, 5 times 2x squared is 10x squared. So I'm just going to go ahead and match that up. Alright, 10x squared. 5 times 5x is 25x. And that doesn't have a like term, so I'll just put it over here. And then 5 times negative 3 is negative 15. So all we need to do now is combine the like terms. Excuse me so much. So this is going to be negative 8 x to the 4th power minus 20 x to the 3rd power plus 32. What? Wow. So this is my 3rd night in a row with less than 3 hours of sleep. So that's why I can look at this and think 30 somehow. 22 x squared, and then we have 25x minus 15. Still trying to figure out where I was getting 30 from. So this would be the answer to number 8. And okay, this video is long enough, so I'm going to end this recording now. We will pick up with number 9 on the next video. Oh, binomial expansion. What? Little Pascal's triangle. Okay, that's what we'll be doing on the next video. I'll see you then. Meet me over there.